Hello, welcome back. This is Processing Motion, Part 1. Today we're going to talk about what it means to be at rest, and we're also going to learn how to draw things on the screen that just sit there and don't move. So let's start out with some notes. First, we're going to think about the Aristotelian view of being at rest. According to Aristotle. Okay. For Aristotle, he was considering the model where the various substances kind of stratify themselves in the following pattern. Earth is at the bottom, and then water, then air, and lastly fire. And these roughly correspond to modern notions of solid, liquid, gas, and plasma. So that if we took, say, a rock, and we lifted it up into the air, its natural motion or natural position would be to return back to the earth, where its similar objects like to hang out. So things tend to group themselves with other similar things, right? So solid objects, natural places on the surface of the earth or as part of the earth. For Aristotle, the earth was completely at rest. It was not flying around in space. It was not, orbiting the sun. It was not orbiting the center of the Milky Way. It was just totally at rest. So for Aristotle, absolute rest meant at rest relative to Earth. Since the Earth is not moving, if you are not moving relative to Earth, then you're also not moving. Okay? But people like Copernicus and Galileo, who came after, sort of changed that perspective. And by the time that Newton came around, it had been pretty well established that the Earth was in fact moving, that it was not at rest. So Newton adopted sort of a Cartesian view of space, where you had kind of a grid, and on this grid were individual points, and these points in space don't move. Points in space do not move, okay? So if you have an object that is at this point, at t0 and at t1 and at t2 and so on, that means it's just hanging out there. It's totally at rest. It's not moving. Whereas if you have a different object that, say, at t1 or t0, it's at that point, and then t1, it's at this point, and at t2, it's at that point. This object's moving. It's moving relative to space, and that's the definition of motion. Whereas being at rest relative to space puts you at rest. So for Newton, absolute rest means at rest relative to space. Okay? Sometime later, we got another famous gentleman by the name of Einstein, And for Einstein, things sort of change. He dramatically changed our view of space and time while investigating the nature of light. And he declared that objects are at rest relative to one another if they have the same velocity. And conversely, objects are moving relative to one another if they have a different velocity, right? And furthermore, space itself can curve. And points in space can move. So unlike Newton, who believed that points in space were stationary and so you could be at rest relative to them, Einstein claimed that since points in space move, there really is no such thing as being absolutely at rest. You're always moving relative to something. You're always moving relative to even some points in space. You're always moving relative to other objects. So if you're at rest relative to the Earth, well, you're moving relative to the moon. If you're at rest relative to a certain point in space, well, you're moving relative to other points in space. And so there's no really special point of view or special reference frame. So for Einstein, absolute rest. I think we switched that around a little bit. Is an illusion. Okay, so keep that in mind as we work with our computer code. Now we're going to switch over to the computer and start typing some of this stuff up and see what we can do. So before you learn how to move objects around on the screen, we first need to learn how to draw in general. And with your processing sketch, you'll generally start with the setup function. Sometimes you'll see global variables declared before setup, or maybe some other code up here. But for the purpose of just drawing some shapes to the screen, we really only need setup. So we're going to stick with that. And first you need to decide how big you want the window to be. I'm going to go with 800 pixels by 600, so kind of a rectangle. And I'm going to make the background I guess a dark gray. I have kind of a black color here, so when I open up that window, let's go ahead and look at it. That looks good. I wanted there to be a little bit of contrast so we could see it clearly. Okay, so we've drawn a gray background. Let's think about drawing some shapes, right? So first let's draw a circle, and the easiest way to do that is with the ellipse function. Let's draw this thing kind of on the right side of the screen and pretty close to the top. And we'll do 75 pixels wide by 75 pixels tall. So with the ellipse function, in the special case where your width and your height are the same value, you get a circle. And we can use the fill function to determine the color. I'll make this one red. So quite a lot of red, no green, no blue. We'll draw a red circle. And it worked. Okay, so I don't know, let's draw a square maybe, which can be done with the rectangle function. Let's move it sort of down the screen a little bit. So I don't know, we'll still be over on the right side, but we'll move it down to say 400. And we'll make it 80 pixels wide and 80 pixels tall. Since those two are the same, we get a square instead of a rectangle. And then let's make this thing green. So no red, quite a bit of green, no blue. And the main thing to keep in mind here is the default setting for an ellipse is to place it the center of the circle, or the center of the ellipse, at the XY positions given here. For a rectangle, it places the top left end of the rectangle, the top left corner, at that XY coordinate there. So let's see if we get our green circle to show up. Cool. So we have our, green square. We have our red circle, we have our green square, and you may be wondering, well, how do I draw sort of weird shapes or abstract shapes? So let's go ahead and make one. And I think we probably want begin shape here. So with the begin shape function, you just list a set of vertices, and it will connect the dots between those to draw your shape. So I don't know, maybe we should do 4 or 5 vertices to kind of draw something a little bit unusual. How many is that? 1, 2, 3, 4, 5. That should be good. And then you tell it to end shape, and we'll put in the command to close it so that it closes the shape out. So we need to kind of, all these are obviously at the same point, so we need to tweak these a little bit. So we'll put in some kind of random numbers so we can get an atypical shape, maybe one that we're not familiar with, like a triangle or something like that. Make this thing kind of big. And I don't know, it might be kind of nice to start and end at the same X position. So what color should this be? Maybe blue this time. 0, 0, 200. So no red, no green, lots of blue. Oh, that's kind of cool. I don't know, maybe we should move that last point. See if we can put a little tilt in that line. Right now it's parallel. Okay, cool. So we have this sort of abstract blue shape. We have a nice red circle. We have a nice green square. And as you're drawing these things to the screen, keep in mind that we're using, you know, if you're thinking about the beginning of the video, we're really using a Cartesian or a Newtonian type viewpoint of being at rest or being in motion, because we have this XY coordinate system and we're keeping track of that here. We're locating objects based on their location relative to points on the screen. So we're not in a kind of a crazy curved space like Einstein. We're not really referencing being at rest relative to the Earth like Aristotle. So Newton would be very comfortable with the scheme that we have going on here. So let's paste this into P5 and see if we can just tweak this code to make it work. The first thing we get is this little error here. What is it saying? Missing semicolon. So P5 doesn't use void, it uses function setup. Calls them functions because that's what they are. And instead of size, it says create canvas. So there we go. Now it's this kind of red color, so we can see that it's the program knows what we're talking about now. So with this code, I think rectangle, ellipse, fill, vertex, begin shape, all this stuff, I believe P5 knows what's going on. So the only thing we really needed to change is void becomes function, size becomes create canvas. Let's play it. And it does open up in the browser, which is cool. And we still get our circle, our square, and our weird blue shape. So that worked pretty well. All right, so last thing, I want to point out a couple references down here. You can go to processing.org/reference, and this has a lot of information about the code, how to draw things, and what's especially relevant to what we did today are these 2D primitives. These are the two-dimensional objects that are built directly into processing language, and we have 3D primitives down here, box, sphere, and you can do things like begin shape. You can click on all of these and read about how to create these shapes. And P5 has a very similar thing, p5js.org/reference, and you can see here are the shapes. Here's the 2D primitives. Here's the 3D primitives. We get a bit more variety with P5, which is kind of cool. I'm looking forward to kind of experimenting with these. And the same kind of concepts, right? Begin shape, draw these things. So that's it for the at rest video. Next we'll talk about linear motion and moving objects around on the screen at a constant rate.